Welcome to our study on calculus. Today we look at differentiation of a function or differentiation of a composite function. So in the first video on differentiation, we had equations like y is equal to 2x to the power 3, and for us to get our dy dx, all we had to do was multiply the coefficient times the power first. So 2 times 3 to give us 6. Then we get the x as it is, then reduce the power by 1. So it's 3 minus 1, which is 2. This was our dy dx. Today, what we have is an equation inside brackets, and the brackets having a power different from 1. So it can be 1, it can be 2, it can be 3, just not 1. It can be a negative power. So then what this means is we have two functions. We have this function inside, and we have these brackets making us have another function, so to say, because this power can't be distributed without expanding the brackets. So for us to get our dy dx for composite functions, we start the same way that we started, multiplying the coefficient times the power. So we multiply the coefficient, which is 4, times the power, which covers the entire equation, which is 8. So 4 times 8 will give us 24. We open our brackets, then we have 2x minus 3 to the power reduces by 1, so it's 8 minus 1, which will give us 7, times, I made a mistake in my first video, I was adding here, please, it has to be times. So then we multiply times the derivative of what's inside. So we differentiate what's inside the brackets. Derivative of 2x is 2, derivative of a constant is 0, so all we have there is 2. So we have 24 multiplying what we have in the brackets there. 24 times 2 will give us 48. We open our brackets, 2x minus 3 to the power 7. This then becomes our dy dx equation. We write our equation y to be 2. We open our brackets, t squared plus 3 to the power half, knowing so well that half is equivalent to having the power raised to half. So we have that. So to get our dy dt, notice it's not dx because what we have here is t. So dy dt then is the coefficient times the power. So we have 2 times half. We open our brackets, we write what's inside as it is, t squared plus 3 to the power, the half, or the power reduces by 1 to give us negative 1 over 2 times. We differentiate what's inside the brackets. Derivative of t squared will give us 2t. The derivative of 3 is 0. So then this will give us, this and this will cancel, or they will divide to give us 1. Then we have this one here, t squared plus 3 to the power negative 1 over 2 times 2t. And that will simplify to dy dt being equal to, what we have is a negative power, meaning this can be taken down. So we're going to have 2t remaining on top over t squared plus 3 to the power half, and the power half the same as the square root, so you can write that one as 2t over square root of t squared plus 3, and you are done finding the derivative. So for our final example, we write our equation y for us to easily differentiate it using our formula of differentiation. So we have y is equal to 2, whatever is on top of the fraction we keep it as it is. Then, sorry about that, we push this one on top to give us x to the power 3 minus 3x minus 4. We close our brackets. So what we have here is this equation to the power 1. We bring it up or we push it up, we introduce a negative sign, so the power is negative 1. So to get our dy dx, multiply the coefficient times the power. So 2 times negative 1 gives us negative 2. We copy what's in the brackets as it is. We have x to the power 3 minus 3x minus 4. Close our brackets times. We differentiate what's inside. So inside, derivative of x to the power 3 is 2x is 3x squared minus the derivative of 3x is 3. Derivative of a 4 is just 0. So then this simplifies to, so what we have this constant here which can multiply. Forgot to put the power here. This one reduces by 1, negative 1 minus 1 will give us minus 2. So then this constant here, we have negative 2. We have a negative power, so meaning this one can be pushed back down to make a fraction, so that we can have x to the power 3 minus 3x minus 4 to the power. Because we've pushed it down, the power becomes positive, so we have to the power 2 times, we still have this thing on top here, which is 3x squared minus 3. So then this just simply means that our dy dx is equal to negative 2 3x squared minus 3 over x to the power 3 minus 3x minus 4 to the power 2 as the derivative. So that's how you differentiate composite functions. Thank you.